Good morning, my wonderful students. Been a little bit since I've taught you guys a lesson, so I'm back. We're going to continue our quadratics here. Now we're going to start graphing quadratics, all right? So, um, let's get started with our Quatio Nuke agenda, as we always do, all right? Right now you should be trying to solve the Nuke agenda. Whichever method you want to use for solving quadratics, just make sure you set equal to 0. So take a pause now. That's my little maverick barking because he wants to be involved. Take a pause now and set equals 0 and solve. Okay, hopefully by now you've already solved it and you're coming to check it. Okay, so let's do it real quick. First thing you should do is subtract 9b and add 20 to both sides. All right, so when you do that, you're going to get n squared minus, oh, sorry, that should be a 9n, not a 9b. I apologize for that. That should also be an n, not a b. My bad. All right, so just make this easy on us. Here, I got an idea. Maybe I'm going to do another n down here. And let's just drag this baby over. So that should be 9n. I apologize again. So we have n squared minus 9n plus 20 equals 0. All right. I don't know what these little marks are. Let me get rid of them for you guys. All right. Now we solve. I'm gonna factor. It's just for me a little bit easier. I recognize it already. If you factored, you should add n minus 5 and n minus 4. And those two equal 0. All right. And then after this, set each one equals 0 and solve. Well, no matter what method you use, whether you use quadratic formula, whether you use complete the square, whether you use this, you should have gone n equals 5 and n equals 4. All right? All right, so let's take a look at what we're doing today. So, first thing you gotta know is that a graph of a quadratic is called a parabola. All right? A parabola looks like a U shape normally. If you guys look at what's on the screen right now, it explains why it's either right side up or upside down. This is right side up when there's an opening going up. Okay, hey bud, calm down. When there's an opening going up. So as you can see right here, we have like a U shape where the 2 arrows are going up, and there's nothing more going in the bottom direction. It has what we call a minimum point down here. All right, minimum point. That means it doesn't go any lower than that point. On the flip side, if you have a negative x squared, so that means that the coefficient in front of x squared is negative, or there's a negative sign there in any way, shape, or form. If you have a negative x squared, then the parabola is going to look like an n. It's going to be upside down, all right? The opening is going to be facing downward. Hey, bud, relax. Calm down. All right? If that's the case, then up here, this is called the maximum. All right, that's called the maximum point because that means that you can't go any higher than that point. So again, on the left side, examples of that would be x squared, 2x squared, 10x squared, anything with a positive coefficient. And on the right side, negative x squared, negative 2x squared, negative 10x squared. Same thing, just a negative coefficient. All right. So when a quadratic equations contain quadratic equations contain a what? What do you think we're going to contain here? If you answered solutions or zeros or roots or a vertex, anything along those lines, there's a bunch of answers you could use. But what quadratic equations always contain is a square, all right? And that just reminds us that x squared means that's a quadratic equation, all right? All right, so let's look at what we have here. Now, when we solve quadratics by graphing, that's what we're going to be looking at today. We're going to be looking for our solutions, our zeros, our roots, whatever you want to call them, okay? And when we graph them, the way we can tell our roots is where it crosses the x-axis. Remember something. Whenever we set these things equal to 0, that's essentially saying y is equal to 0. Okay, whenever we set an equation equal to 0, we're essentially saying y is equal to 0. So if y is equal to 0, what we're going to look for, our solution, is where y equals 0 on the graph. All right, right here, the x-axis, all y values are 0. For example, if we look at these 2 points, this is 2, 0, and this is 6, 0. So that's how we know that these are our answers, because the y value right here is 0. All right, so our solutions then become 2 and 6. Excuse my bad brackets. But those are our two solutions. Those are our x values. Whenever we solve quadratic guys, you guys have been saying x equals, x equals, x equals. So this is x equals 2 and x equals 6. And another good way, you don't have to really remember y equals 0, just where it crosses the x-axis. All right? All right, so let's look at our next part. All right, so these two things. Now, these things are very important. The first thing you need to know for quadratics, and this is going to help you get started in pretty much every graphing quadratic problem, is your axis of symmetry. Now, your axis of symmetry is literally an invisible line, and I'll show you in a second, an invisible line that goes directly down the middle of the parabola. And if you were to fold the graph over on itself, over that line, it would be perfectly symmetrical, which means it would line up perfectly on either side. All right, so this is the formula for it. Very important. You have to remember that formula. All right, x equals negative b over 2a. Now, that axis of symmetry, that x value, is the x value of our vertex. Every vertex is a point. All right, as you can see right here. Every vertex is a point. Oh, that's a little higher than I want it to be. Every vertex is a point. Really important for you guys to understand that. It has an x and a y coordinate. The x coordinate is your axis of symmetry. All right, so that x coordinate, let me lower that again. That x coordinate, that's your axis of symmetry. So that's why it's always important to start off with the axis of symmetry. And then as you can see in our picture right now, your axis of symmetry is that invisible line right here, all right? That dotted line. That's where it's directly in half, okay? And as you can see down here, that's your vertex. Now, remember in the 2 slides ago, let me go back really quick. We talked about a minimum and a maximum. The minimum and maximum is also known as your vertex. All right, your vertex is going to be your highest or your lowest point of the parabola. That means that the picture isn't going to go any higher or lower than that because the opening is the other way. Okay, so key axis symmetry first, then we find our vertex. Okay, let's do an example of that right now. So here we have y equals 3x squared plus 6x minus 4. You guys will notice that it is not equal 0, and we're not going to set it equal to 0 because we're graphing. So we're going to have it set equal to y, all right? So remember, when it's set equal to y, you're graphing. When it's set equal to 0, you're solving. Okay, so our first thing is to find the axis of symmetry. So we have to use x equals negative b over 2a, all right? Now, we all know where to find our a's and b's. I hope you guys remember. A, B, C. All right. So this is going to turn to x equals negative 6 over 2 times 3. 2 times 3 is positive 6, and negative 6 divided by positive 6 is a negative 1. All right. So that's how you find your x value of the vertex. So if I go over here real quick, I'm going to just change the color for you guys, just so you guys can see the difference what I'm talking about. So your vertex, that's an x and a y. You just found the x to be negative 1, okay? That's what we just found right now with the axis of symmetry. So x equals negative 1, okay? Now, how do we find our y value? Well, remember, if we already have our x value, just like you would do with a normal normal formula, normal equation, normal anything like that, you plug it in to find your y value. So we're going to plug it underneath. So we have y equals 3x squared plus 6x minus 4. We're going to plug in negative 1. Oh, let me lower the screen a little bit. We're going to plug in negative 1 for x. All right. And then we just do our math. If anything, actually, what I would really prefer you guys do is just plug this into your calculator. All right, let me pull out the calculator really quick. And just plug it in just the way you have it here, right into the calculator, and it just makes your life a lot easier. All right, so if you just give me 1 second, there we go. All right, clear whatever's there already. All right, so we're going to have 3 parentheses negative 1 squared plus 6 parentheses negative 1 minus 4. Okay? Then we press enter, and we're going to get y is equal to negative 7. So if we go back here real quick, this is going to equal negative 7, which means y is equal to negative 7. All right? And that's going to be our y value of the vertex, comma, negative 7. All right? And that's how you find your vertex. It's really that easy. Axis symmetry first, and then the vertex. And if you're ever not sure, what you're going to do is you're going to go into the calculator, plug in the formula we were originally looking at, which is y equals 3x squared plus 6x minus 4. And then press second graph. And look for your vertex. If your vertex is here, that means you guys got it right. We had our vertex as negative 1, 7. So if I look right here, I see negative 1 and I see negative 7. So that means I definitely got this right. Okay? Another little hint is if you guys look at the y values surrounding it, they're exactly the same. And that's correct. That's what it should be. Please remember, we're talking about symmetry. We're talking about it looking the same on either side. Let me go back really quick to our graph. So all these y values, this one and this one, this one and this one, all the y values are going to be the same. The only thing that's going to change are your x values. So when you check for your vertex in the calculator, what you also want to look for is all the numbers in the y value that surround the vertex. If they're not exactly the same, then you probably messed up somewhere and you want to recheck your work. But if they are exactly the same, like right here, -4, 5, 5, 20, 20, that means that I did my vertex correctly, and then I can move on and just graph my points, all right? So again, just to reiterate all this, you're starting off with y equals 3x plus 6x minus 4. First step is to plug it into the axis of symmetry, which is x equals negative b over 2a, which is what we did here. Negative 6 over 2 times 3, negative 6 over 6, which is negative 1, and that's my x value. And then we take the x value, plug it back into the original equation, like so, solve for our y value, and that's our vertex, and we're all done there, okay? All right, so now let's look at an actual graph, all right? We're going to answer these questions at the end. So we have y equals 3x plus 6x minus 4. So the first thing I'm going to do is find my vertex. Like we said, that's always important. That's always number 1, okay? So let's look for the vertex first. So I'm going to start off, as always, with x equals negative b over 2a, okay? We just saw this. Sorry, I just realized this is the one we just did. So we know our vertex. I'm here to erase all this. My apologies, guys. It's been a long day for me too, you know. All right. So we just did this. If we go back, this is the same exact problem we just had. So we know our vertex is negative 1, negative 7. Okay, we know that. So we're going to graph that first point. I hope it graphs cleanly on here. We're about to find out. So negative 1, negative 7. Oh yeah, good. It graphed perfectly there. Okay, good. So now we're going to go back to our calculator, just like we had it, And we already have the rest of the points. So guys, once you find the vertex and you confirm that this is your vertex, graph the points around it, all right? Graph as many as you can. You want a minimum of 5 points. If you can graph more, great, but you want a minimum of 5. So I have -1, -7. My next point is going to be 0, -4, which is right there. I'm trying to make it a little bigger so you can see it. My next point after that is going to be 1, 5. So 1. Okay. After that is going to be 220. I can't graph that. That's too much. So I'm going to go now to the left side. So I just graphed 0, -4, and 1, 5. Now I'm going to graph -2, -4, and -3, 5. All right. So -2, -4, and 3, 5. So as you guys can see, the y values are exactly the same. It's just the x values that move that are different left to right. All right. And then we're going to just graph our parabola. Sorry, I know my parabola isn't as circular as I want it to be. My apologies. It should look more like a U. Hopefully you guys can do it a little better than I just did. All right. But it should look more like a U than this malarkey that I just put up here. Sorry about that. All right. But it's going to be a skinny U for this problem. All right. So you find the vertex. You plug their equation into y equals here. Second, graph, and then just graph the points around your vertex. You got to locate your vertex first, and then graph the points around it. Okay? All right, let's look at another problem. Oh, I'm sorry, wait. We didn't answer the questions here. So is there a minimum or maximum? Yes, there is a minimum or maximum because that minimum or maximum is your vertex. So there's always a minimum or maximum. Okay? And is there a y-intercept? Of course there's a y-intercept. You want to look at where it hits the y-axis. All right? So in this case, this is my y-intercept. So my y-intercept is equal to -4. All right? Whenever your x is 0, that's your y-intercept at that point. Okay? All right, so let's look at another problem. All right, so for this problem, it says find the axis of symmetry and vertex, maximum or minimum, and then it says graph. All right, so we've got to make sure we do all these things right now. So let's start off with our axis of symmetry. That's how we always start these problems off. So x equals -b over 2a. My b in this case is 4, so x equals -4 over 2 times -1. Guys, keep in mind here, we have a -1. So chances are that this graph is going to be an N shape, an upside down, all right? So just get ready for that. All right, so now we have -4 divided by a -2, which means x is equal to 2, okay? X is equal to +2. Now we got to plug it in to the rest of the equation to find our y value. So we have y equals negative. Now I want to keep something in mind here. I want to point something out. There's no parentheses around the -x squared, which means it's negative times x squared. All right, so do not put the negative inside the parentheses. That is so important. Please be careful with that. Okay. And now let's just plug this into our calculator. And again, just like you see it here, you don't have to change anything. Negative parentheses 2 squared plus 4 parentheses 2 minus 6. And we get an answer of -2. So y is equal to -2. So we have our vertex now, okay? We have our vertex, also our max slash minimum. All right, they're both the same thing. So our vertex or maximum minimum is 2, -2. Okay, Remember, these two things up here are the same thing. Those two things right here are the same exact thing, vertex and maximum minimum, okay? All right, so now let's graph. We figured out our vertex. Let's make sure it's right, actually. So actually, let's go back to the calculator, go to y equals, and now let's plug this one in. Negative x squared plus 4x minus 6. And we go a second graph. First thing I'm doing is looking for my vertex to make sure that it's correct. Go down here. I see 2. I see negative 2. That's the same as my vertex. Pretty sure I'm right. And then I'm looking at the numbers around my vertex, and they're all the same. So I'm definitely right, okay? I have negative 3, negative 3, negative 6, negative 6, negative 11, negative 11. So that's a good indicator that I am correct. So now we're just going to graph them. All right, so let's move this over so we can see our points as we graph. We always start off with our vertex. So we're going to start off at 2, negative 2, which is right there, okay? And now, when we graph these, we should be going down. Because remember, it's a negative x squared, which means it should be an N shape, okay? So my next point, going positive here. So I have 2, negative 2, 3, negative 3. And then after that is 4, negative 6. Which is right down here. And then after that's 5, negative 11. That's too many spots. That's off the graph. So now I go to the left side. So I got 1, negative 3. I got 0, negative 6. Sorry, I put that first one in the wrong spot. Let me fix that real quick for you guys. Okay, so 1, negative 3. And then I got 0, negative 6. Again, I'll make that a little bit thicker so you guys can see it. And then after that, it's negative 1, negative 11. Again, that's too many spots off, so we're good there. And now we just graph it. Again, hopefully your graph looks better than my graph. It should be more U, all right, less squiggly. So this is our maximum minimum, as we know. In this case, it's our maximum. Okay, and the last question asks what the y-intercept is. Here's our y-intercept. Again, let me change the color for you. So here's our y-intercept of 0, negative 6. So our y-intercept is negative 6. All right. So it's actually pretty quick. The most work you have to do is just to find the vertex. You always have to show work for the vertex or you don't get your credit. So besides the vertex, everything else is pretty simple, okay? Plug it in, look for your points, and then just graph them. All right, so this is your practice problems. You should be find the vertex for all of them, show the work for the vertex, and then graph the rest. You do not need to show the work for all the points. You only need to show the work for the vertex, all right? Hopefully this video wasn't too confusing. If you guys need help, you know I'll be available. I'll see you later on my Google office hour, all right? Have a great day, guys. I miss you guys a lot. Hope everyone's safe. Be good.